Okay, so yeah, if you're just joining us, you can just pause and look at this, and then we go on. Okay, hopefully that makes sense. Okay, so let's go ahead and do this. In the purple over there is what we're working on now. That means du is 1 over t dt, and v is the antiderivative of this, which is 1/5 t to the 5th, uh, no dt. So this is what I'm focused on right now. So I'm going to ignore the other stuff, the natural log of 3 over 5. That we'll put it back in at the end. In fact, to remind me, I'm going to do this. There. To remind me to put it back there. We'll put it back when we get down there. Okay, so this is going to be u times v minus the integral of v du. So u times v is 1/5 t to the 5th natural log of t minus the integral of v du is going to be 1/5 integral of t to the 4th dt. Now, before you go bonkers, this times that is 1/5 t to the 4th. One of those t's cancels. I'm putting the 1/5 out front. Like I said, I'm doing this quickly. Stop me if you need me to. Okay, almost there. Don't worry, that arrow is still there. Last step. So we have maybe I'll just a sec. Let's just go down here. 1/5 t to the 5th ln of t. We've already got that. And then the antiderivative of this is going to be 1/5 t to the 5th. So that'll become 1/25 t to the 5th. Now let's bring that thing back that I said I was going to bring back. So let me copy it down here. Natural log of 3/5 t to the 5th. There we go. So there's my antiderivative. And now all I got to do is put in the limits. So I'm bringing the limits back as well. Was it 1 to 4? Yeah, 1 to 4. So here you just have to deal with yeah, it's going to be ugly. Okay, so we got natural log of 3. I'll write it down. Over 5 times 4 to the 5th. 4 to the 5th is 1,024, is that right? Plus, let's see, 4 to the 5th natural log of 4 over 5 minus 4 to the 5th. Lots of 4 to the 5ths. That's the upper limit. Don't neglect the lower limit. There's the lower limit. I know, I just did it all in my head, but you could do it in your head too. When t equals 1, oh, no, I didn't do the lower limit correctly. Darn. I was so excited about it, I messed up. Get rid of this. I'll write it out. Okay, so then this is going to be minus natural log of 3 over 5 plus 0 minus 1 over 25. There we go. I had a student in my first class who typed something not exactly this, but it was like this. Typed this into Lumen, just like that. No simplification, just basically just the numbers, and it marked it correctly. So if you don't want to have to go through the hassle of simplifying this, you could always just try typing it in and see if Lumen likes you. And if it does, you'll get it right. So I know I blew through that, Jackson, but did that at least give you some hint as to where you might go with this one?
So yeah, so the reason why we did all the work before the iteration by parts is because it had two values inside the natural log.
Yeah, I had to deal with that. You know what?
Like we split it into two other natural logs because it's 3t instead of just like t.
Hold on a sec. Let me see this. Maybe I didn't have to. I was just I wanted to show off. That's why we did that. Well, let me move over here just a minute. Let me try again. Let's try it one more time, but I think, yeah, I don't think we needed to. Now that you mention it, that was just me showing off. It's always bad. You know, that's usually famous last words, right? Hey guys, watch this. Anytime you're trying to show off. It's nothing good can come of that. Okay, yeah. I'm pretty sure that this is all correct, but you're right. I didn't really have to do that. I could just do u equals natural log of 3t, and then du is equal to 3 over 3t. So the reason it's 3 over 3t is because of the chain rule. So you do 1 over 3t times the derivative of this, which is the 3 there. And then dv. Yeah, I was dumb. Why did I do it that way? So much easier this way. dv is equal to t to the fourth dt. V is equal to 1/5 t to the, oh, this is a dt here. Okay, t to the fifth. Okay, you would get the same answer. I'm just going to say that as a blanket statement. I'm sure that I did all of my algebra correct. But yeah, this would have been quicker, wouldn't it? Well, why do you need help if you knew how to do it in the first place?
Well, I got the integration of parts like sequence down, but I must have done something wrong with the like math.
Maybe the chain rule. This is easily overlooked here, this 3. Yeah, so that might be an issue. But yeah, the rest of it, it's going to be similar, a similar level of suffering as you go through the rest of this. Wow, yeah, why did I even do that? Like I said, yeah, showing off. Pride. I need to repent. Okay, what else do we need to look at? Anything? Yeah, what do you think, Andrew? Number 4? Wait, are we working backwards now? I think we are. Because that was 5, wasn't it? Oh yeah, number 4. Oh, come on. Okay. This is 7r. Whoops. Why is there an r there? Why can't it be just x? Okay, 7r plus 4. Oh, natural log. Darn it. Where's my natural log? Hold on a sec. Natural log, is that better? Okay, I got it all. dr. Okay. I'm not happy about this, but I'm going to do it. So we're going to do it this way. We have u is equal to the natural log of 7r plus 4. And then dv is equal to dr. du is equal to 1 over 7r plus 4 times 7. I'll just put the 7 up there. dr. V is equal to r. So far, so good with the... So the main issue here is going to be with the next step. After we get done doing our integration by substitution, or integration by parts. So this is going to be this. You've got uv. Okay, the uv is easy. It's the important thing is the v du, right? I better write down the uv. Okay, uv ln of 7r plus 4 times r minus 7r over 7r plus 4 dr. That look all right? So it's this point, right? This is the place. We're all stuck. What do we do with that? Oh, we're done. Okay. Well, let's take the quiz. No, I'm just kidding. Let's finish this one. And then, so I guess you have to get your questions in early if you want them answered before the thing shuts us down. So yeah, this one, now we'll just do a straight substitution. So here we do let's see. So there is the integration by parts. And now we're going to do substitution. I'm going to just change color to make sure you emphasize that this is a different u. So u is equal to 7r plus 4. Du is equal to 7 dr. So we're going along happy so far. And what we end up with is, I'm just going to take this piece right here and stick it down here. Is we can do this, r over 7r plus 4 times 7 dr. So everything looks good until you actually try to do this substitution. And when you do that, you say, wait, u is equal to this, du is equal to that. Everything's cool. But then what is that doing there? That is a problem. I don't like that. So because of that, we have to do a little bit more work. And the little bit more work that we do is we take this thing and just solve it for r. So let me get rid of that arrow because it's in my way. So so that means that r is equal to u minus 4 over 7. Okay, so now I have substitutions. I'm going to use this substitution up here. I'm going to use this substitution down there and that there. So let me just do those, and then I'll do one more step, but I will not go further. I refuse. So here, this becomes u minus 4 over 7. That's that substitution for the big numerator of this big fraction. The bottom of the fraction becomes just u. This becomes du. Let me just do one more simplification, and then I'm going to cut you loose. So the next simplification is this. I take this, okay, I'm going to do 2 more steps. I was going to do one, but I thought I don't want to just leave you hanging. So one more step, and then you're going to all be able to like, oh yeah, that's easy. So this is going to be u over 7u minus 4 over 7u. Now the rest of this you can do in your head. Specifically, u over 7u is just 1/7. Integral of 1/7 is just u. This is 4/7 times 1 over u, so that'll be 4/7 times the natural log of u. Then go back, put in whatever we had at the beginning for the substitution, this one right here, that u equals 7r plus 4, and you'll be all set. So yeah, that one was a little bit complicated and annoying, and now I guess the due date has been reached. Now the quiz that I have for you is not annoying. The quiz is, I think, one of the easiest of the integration by parts problems. But despite the fact that it's easy, please do write all of your steps. What I mean by that is this stuff, the stuff that I have in the box there. Put your u, put your du, put your dv, and your v. So put all that stuff. It'll be, of course, different for the one on the quiz, but put it down. It'll be an easy one. Just one problem, just to give you a little bit more practice, to prove to yourself that you know what you're doing. I'm very excited for you, but here, maybe you can send a couple of those back there, and I'll come around and help make sure everyone gets one. There's an extra one. Here, you need one more here. Very nice. There's a few. That's probably not enough. Let's give you one more just for fun. You want those? That may not be enough. Tell me if you need more. No? Yes? No? Yes. Right. You got enough? Perfect. Sorry. There you go. This is going to be too many. That's still too many. Did everyone get one? Oh, so much excitement. By the time I get it loaded up into my iPad, you're going to have it done, I can tell. Where's my glasses? Yeah, obviously, I don't want you to punch this into your calculator, except to check your work if you really want to. But yeah, you do it by hand. Show me you know integration by parts, basically. hopefully you're coming down the home stretch with this thing. Not a super challenging parts problem, but there are a couple minor things that might trick you up. So don't get too fancy on it. It's okay. It looks like people are finishing up. If you do get done and you want to see, you done? Yeah. You want to drawing with the lines? Sorry. Anyway, if you are done and you want to get rid of it, you can send it over to some notes here and I'll put it with all the rest of its friends. Alright, if you are still working, try to wrap things up. You can move on to the next joyous integral to energy thing. Something? We're not happy with your energy? Got something? the general formula. Arithmetic. All right, everyone else, we got a couple more here. You got one you're gonna get rid of? Yeah, let's get rid of these. We can purge. Any others? You've got one? All right, get rid of this one. All right, yeah, get it off your desk so that you don't have to think about it anymore. I've got them all. Crunch. Okay, let me show you what I did. And hopefully you did something similar. Even if you were not successful in finishing this thing, hopefully at least you were able to break it up into the integration by parts here. So u equals x, dv equals this stuff, du is easy enough. V is a little bit more challenging because you might either remember that the antiderivative of 2x is 1/2 e to the 2x, or you could use substitution. I wouldn't want to have to do that if I could avoid it, but you could do u equals 2x, du equals, yeah, it's a different u than that one though. Du is equal to 2 dx, and then deal with that, and you get this eventually. So anyway, that's that. With that though, the rest of this just kind of falls out because you do uv minus v du. So here's uv minus v du. So mainly it's just sort of keeping track of everything, making sure that you don't lose anything in the wash here. So there's the antiderivative of this. I just applied that a second time because antiderivative of e to the 2x is 1/2 e to the 2x, so there's the 1/2 times the 1/2. And then I plugged my limits in, and then the limits, I ended up with this stuff. So that's the limits. Oh, I rearranged a bit before I plugged limits in. So this is the upper limit. This is the lower limit. Don't neglect the lower limit here. E to the 0 is not 0. But anyway, getting down here, this is what I got. I saw some people had said that's approximately 2.09 or something like that. So I'm going to hope that that's the right answer. I mean, I know this is the right answer. I don't know where the 2.09 came from, but hopefully you know what you're doing. All right, we're good? Sort of? Maybe? Good. Yeah, we're moving on. Okay, today we have one type of integral to deal with. One type. So, but it comes in a bunch of different flavors. I've got them written down here. Here's the type. If you can understand this one, then the rest of them are going to be similar. So let's take a look at this one. Sine squared times cosine. What's the antiderivative of sine squared times cosine? I'll bet you can do this. In fact, I'm so confident. By the time you have it written down, I will have chosen some volunteer to do it, at least get us started. So give me a sec. There's that glasses. All right, let's get going with this one. Hopefully you've at least got it copied down. So Logan, when you look at this thing, what does that, first of all, do you have any ideas? You're going to use some u substitution, right? Very nice. So before I do that u substitution that Logan wants me to do, I just want to rewrite this just slightly to fit his substitution. So I'm going to do it like this. This is equal to the integral of the quantity of sine of x squared times cosine of x dx. Yeah, and then we'll do Logan's substitution. What he wants us to do is to let u equal sine of x and du equals cosine of x dx. Seems super easy, doesn't it? In fact, it is super easy. In fact, it's hopefully have enough room here. This becomes the integral of u squared du. Let's find another volunteer. Drew, you know what the antiderivative of u squared is, don't you? And don't forget the plus c because this is an indefinite integral. And now we go back to sine of x, and this becomes sine cubed of x over 3 plus c. Let me just give you a minute. I know I blew through that super quickly with the help of Logan and Drew, but you might still be confused as to where Logan got his sine of x, or maybe where Drew got his u cubed. Let me know, and we will pause and try to explain. But if not, we're going to barrel on ahead pretty quickly today. Okay, so this is the basis for everything that we're doing today. Today we're going to deal with how to deal with functions that are products of a whole bunch of different trig functions. So typically you don't see a lot of these in the real world, but if we can master the more complicated ones, then the ones that we do see, the simpler ones will become easy. This one is a simple one, by the way. This, easy. So as long as you recognize you're doing a substitution. Let's take a look at another one of these. Here's level 2. So I've got these arranged. Got level 1, level 2, and beyond. So let's take a look at level 2. So let us do the, here, let's just do this. Let's let Cooper. Cooper, what do you think? What would you like to do this one? Okay, yeah, but just like with Logan, instead of using sine cubed, I think I'd like to use u equals just sine. Is that all right? Yeah, so that makes more sense, because if you use sine cubed, yeah, wait, could you do that? Hold on a minute. No, because the derivative of sine cubed is 3 sine squared times cosine. Yeah, that's just complicated. We don't want to deal with that. So let's think in terms of this. So I'm just going to copy this down. Since, yeah, this worked before, shouldn't it work again? Let's give it a go. Okay, so there's my substitution. So let's see, this means that we have the integral, and I will just do this directly from what you said. The integral of sine cubed x cosine of x times cosine of x dx. You know how I am. I like to isolate the thing that I'm going to replace the du for, get it all by itself, so that I can make my substitution nice and cleanly. So this sine cubed is u cubed. That's where that goes. This thing becomes du, but what does that become? That's the problem, isn't it? This one, I've got nothing for the cosine of x to become. What is it going to become? Someone want to make something? No, yeah, you could say, oh, it's du over dx. That's no good. You can't do that. So, sadly, I got nothing. So this doesn't work. So, ooh, who could it be? Wait, is this someone important? It might be important. Let me check, just a second. Hello? 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 Apparently not. Sorry. I've been trying to get my doctor on the phone, so I don't know what his number is, though. Well, I know what his number is that I call, but I don't know, it could be some rando. It probably must have been. Maybe they'll call back. It's weird that it shows up on the iPad for everyone to see. Everyone you could call that number and find out. It's probably some telephone solicitor. No one answered. There was no one. I could put it on speakerphone next time. Yeah, robots. Yeah, okay. Oh, we got to move on. So if they call back, though, well, we'll see. Okay, so maybe I'll just let it go to voicemail if they call back, and then I'll just play phone tag with them. So this doesn't work. So what are we going to do? We're going to give up, right? No, we're not going to give up. We will never give up. What we're going to do is we're going to scrap this idea. That's not working for us. Get rid of this stuff, and we're going to try a different method. So you might say, well, what is a different method that we could use? Well, if we can't substitute u equals sine of x, let's try the opposite. Let's try substituting u equals cosine of x. Can't we do that? There's nothing wrong with that. Let's do it. U is equal to cosine of x, and then du is equal to, look at that. They messed up. Where's my, there it is. Okay, next person. Rachel Potts. Rachel P., what is the derivative of cosine? It is negative sign. Very nice. So if I made this particular substitution, let's see what this is going to look like. So I'm going to go ahead and barrel on ahead blindly, maybe not so blindly because I know where this is going. So not at all blindly for me. Times negative sine of x dx. I have to have a negative. Okay, so just let me explain what I did from the black to the blue is I just rearranged things. The black and the blue are identical. I've just rearranged things so that I had the negative sine of x dx in a little grouping, and so that negative, it all balances. So nothing tricky. Okay, so as I think through what's going to happen here, this stuff, just a minute, I need to make room because I see poking out. There, I'll put that there. I'll move this up. I see the next problem rearing its ugly head down there. Okay, so I think that I have enough room now, though. Okay, so as I think through this, here's what I'm looking at. I'm actually imagining, look, no, that's the problem, isn't it? I have cosine squared. I can make that into u squared, can't I? U squared. I have this negative sine of x dx. I'm going to turn that into du. I'm good so far. But then I run into a slight hiccup here with this. What do I do with sine squared? Now, you might say that I just threw up my hands just a minute ago. Oh, I erased it, didn't I? And not only did I throw up my hands, I gave up. I put the frowny face there, and I said, let's try something else. Isn't this basically the same as what I had there? Well, it is, but it really isn't. See, the difference is that this is sine squared. What I had was a cosine, just a stray cosine. But if I have a stray sine squared, I can do something with that. And specifically what I can do with it is I can go back in my memory to sine squared plus cosine squared is equal to 1. And just remember that, hey, sine squared is the same as 1 minus cosine squared. Isn't that amazing? And so what I could do is I could go back here and do like a little intermediate step that sine squared is actually 1 minus cosine squared, which is the same as 1 minus u squared. We'll finish this in just a minute, but here's lesson number 2. Lesson number 1 is that you can make substitutions, sine and cosine. Lesson number 2 is that after you make your substitutions, you can use trig identities. And the one major trig identity that you're going to use is this one over here. When that happens, something wonderful happens, and that generally takes that frown and turns it upside down into a smiley face. But anyway, getting back to this, let's go ahead and finish this up. Now that equals, let's see, the integral of u to the 4th minus u squared du. I'll just explain briefly. The algebra I did, I multiplied through here, and then I was like, hey, I'd rather have the u to the 4th be positive rather than negative. So I put that negative back in here, and I got that. Now I can do that. This, in fact, all of you can do this. Tyler can do it. Tyler, what's the antiderivative of u to the 4th minus u squared? Isn't there something else you want to add in here? Of course, I know. Plus c. Now I just go back to my original substitution up there next to the smiley face, and I get cosine to the 5th over 5 minus cosine to the 3rd over 3 plus c as my final answer. Whew. Isn't that amazing? Now, I should caution you about these, is that if you type this into something like Desmos or Wolfram Alpha or whatever your favorite online integration calculator is, you will oftentimes get something very different from what I just wrote down. And it doesn't mean that you're wrong or that Desmos or Wolfram Alpha is wrong or MATLAB or whatever you're using. All it means is that they have a different way of doing their substitution. This way works, and this is the way that I'm going to use, but you might even just come up with something different from me, in which case it's okay if yours looks a little bit different. Actually, it's okay if it looks a lot different, to be honest. But you need to make sure that you follow through on whatever substitution you're doing. Okay, so be aware that you can use substitutions like that. This is the biggie right here. Sine squared plus cosine squared equals 1. And the most common way it's used is either as changing sine squared into 1 minus cosine squared, or changing cosine squared into 1 minus sine squared of x. So those two are going to be super useful. All right, we're moving on because we saw that there was another, there it is. Okay, I got to be honest with you. There are rules. There are sort of these and I am not a big fan. I'm not a big fan of memorizing a bunch of rules because then you blindly follow them, hoping that you're going to get the right answer, and you usually do, but sometimes you don't. But it's so much nicer if you understand the sort of the concept. So let me show you, let me explain the concept here. Is if you have sines and cosines, the idea here is if there are an odd number of either sines or cosines, then you can make a substitution like this. So here's what you're going to look for is if you have sines and cosines, if they're an odd number of either one, then that's the one that's going to become the derivative, the du part, and then the other one will become u. So notice it's the one that's even that becomes u, the power that's odd becomes du. Same thing went down here. Notice that the odd power was the du, and the even power became the u. You had to do a little bit of work with this sine squared that you had left over, but not bad. It's not bad work. You just have to apply this thing over here. So you're going to be okay if you have an odd number of sines or an odd number of cosines or both. If you have an odd number of both sines and cosines, you can go either way. Either do it this way with that substitution or this way with this substitution. But the problem, child, is when you have an even number of both, because there's no way to sort things out and make everyone happy. So when this happens, we're going to use another identity. I know, another identity. Well, let me put your fears at rest. This identity you should have in your brain already, and so memorize it if you don't. Memorize. Okay, how about this? I don't know. I just wanted to emphasize. Memorize it. However, this one, the one that I'm about to use, I'm going to put it, it will be on your test. It'll be there like a little formula. I'll put it on the test so that you know to use it. Well, you might not know to use it, but it'll be there somewhere hidden. No, it won't be hidden. So here it is. Sine squared of x is equal to 1 minus cosine of 2x over 2. This is called the power reducing formula for sine. So it takes the sine squared and turns it into just 1 minus the cosine. You have a similar formula for the cosine, and like I said, both of these I'll print right on any quiz or test that requires them. Cosine of 2x over 2. So those are called the power reducing formulas, and these are what you use if you have to. Don't use them unless you absolutely have to, because they are painful to deal with. So I just try to avoid them, but in this case I will use them because they are useful. So let's go ahead and do this. Since I have only even powers of sines and cosines, I will not be able to do this or this, because both of those require me to be able to separate out one of the either sines or cosines in order to do my substitution. So I'm stuck with this nasty mess. It's okay. I will walk you through this. Here's how this looks. Sine squared is 1 minus cosine of 2x over 2. Cosine squared is 1 minus sine, 1 minus cosine plus cosine 2x. It's written right there. Why don't I just look? Okay, that's better. Okay, so far so good. All I've done is I've made substitutions for those. And these two formulas, only these two, well, I shouldn't say that. There may be more. But for now, guaranteed. Those will be on the test in a couple of weeks, also on the quiz on Friday. They'll be printed. Okay, now what do we do with this? Well, what we're going to do is we're going to multiply through. Let me put the 1/4 out front. And I do FOIL, okay? Do FOIL, and you get one, just a minute. 1 minus cosine squared 2x. I know, I just said do FOIL, and I didn't do FOIL. I did FOIL. I just did it so quickly you didn't see it. It's like a magician, you know, the sleight of hand. But anyway, so you get the 1 squared minus this times this, and then plus this times this. Those two cancel. And then this times this becomes that. Okay, so where are we on this thing? Oh, you know what? We have to use the power reducing formula again, because that's a cosine squared. There's no sine to cancel out when you do the substitution. So I'm going to do the power reducing formula a second time. Now here it's a little tricky because notice that the argument here is 2x, whereas the argument up here is x. So when I apply this, that x always gets doubled. So whatever is here gets doubled. So when I do the power reducing formula a second time, I get 1 plus the cosine of 4x. It's 2 times 2x all over 2. Doesn't look too bad, does it? Okay, I'm going to factor out a 2 here. Can I do that? Well, let's combine things and then I'll factor out the 2. Okay. So this is going to be 1 minus cosine of 4x over 2. Before you go bonkers, let me just notice that this is 1 minus this, so it'll be 2 if I do it 2 over 2. So 2 minus 1 minus this. 2 minus 1 is 1. Do the math. You can handle it. Okay. I am recording, so you can always go and slow things down, although I think you probably prefer speeding it up if you're watching the videos. Now I've got 1/8 times the integral of 1 minus cosine of 4x. All right, we can do this. In fact, Luke can do this. Luke, what is the antiderivative of 1? It's just x. And then, do you want to take a crack at the antiderivative of cosine 4x? Yeah, so it's not times the derivative of that because we're doing an antiderivative. You end up dividing by that 4 there. This is one of those tricks. You should, if you're at all shaky with this, use u substitution here as well. U equals 4x, du is equal to 4 times dx. But in general, didn't I write this down once? I think I did, but I'm going to write it down again. The integral of, is this a cosine? Of cosine of a times x is always going to equal 1 over a sine of, oh, whoops. Come on, Luke, don't, oh yeah, you probably, actually, it was me, not you. It should be a minus there, Shane. You said negative, and you were just carrying the negative down. That was all me making the mistake. Rookie mistake, by the way. I'm embarrassed. That's the right answer. Luke would not forget the plus C either, so I'll put it in for you, Luke. There you go. So questions about that one? We're using the power reducing formula twice there. Sometimes you just use it once, but this is if you have an even number of sines and an even number of cosines. So to recap, we're nearly done, but we have two more to look at just in general. If you have an odd number of signs, you let u equal the cosine, du is the negative sign. If you have an odd number of cosines, it's the opposite. U is sine, du is cosine. If there's an even number, you have to resort to that nastiness. Now, what else could go wrong? Oh no, that's what could go wrong. It's okay. These work almost the same way. By almost the same way, I mean sort of similar. But it's similar enough. Check this out. In the first case here, if you let u equal tangent, then du is secant squared dx. So notice that when you're substituting for tangent, you want to separate out a couple of secants. Down here, yeah, so this is easy. It's going to be the integral of u du. This one, things get a little bit funky, but not terrible. Check this out. If I do secant squared times secant squared dx, here I'm going to let u equal tangent. I know you're looking at this saying there is no tangent. There will be soon. Du is equal to secant squared dx. So this thing has a home. But what's this thing? Well, we're going to do the same trick that we just did with the sines and cosines, specifically tangent squared of x plus 1 is equal to secant squared. Less well known, so I'll put that on whatever test you have as well. So now we have three things I've promised you. But secant squared is 1 plus tangent squared, or tangent squared plus 1. Whoops. Hold on a minute. Let me just put this in here. 1 plus tangent squared. And so that will be 1 plus u squared if you do this. One of the things about this is that it just requires sort of, it's going to be hard because you're dealing with sines and cosines, but once you start seeing the patterns, you'll be like, oh yeah, this is relatively easy. Do your best with this homework. You've got 2 days for it because I'm going to give you the day off tomorrow. If you run into anything weird like this one, is that one weird? No, that one's easy. Yeah, this one, u equals secant. Anyway, try them. And if you get stuck, send me an email. Pop by my office tomorrow. I get bored on Thursdays, and I'm happy to see you. Yes, sir.
The homework was due last Monday.
Last Monday, I will fix that, make it due on Friday. So you don't have to use your late passes. Let me stop the recording. Thank you.